All right, we're going to use this graph for numbers 13 and 14. Graph shows two objects moving at a constant speed. Use the graph to compare the unit rates. So let's look at A. They both use the origin. Now for A, let's find an intersection. This looks good. That ordered pair, these are counting by twos, 2, 4, 6, 8, 10. This ordered pair is 4, 10. So, 4, we're looking for the unit rate. So we need the change in y over change in x. The change in y, 10 minus 0 over the change in x, 4 minus 0, we get 10 over 4, which is 5 over 2. So we would write this equation as y equals 5 over 2x. And 5 over 2 is actually 2.5 as well. We're comparing them, so we might need that as a decimal. B. We're going to use the origin, and let's find an intersection. This one looks good. And that is 2, 4, 6, 4. So, slope is change in y. So 4 minus 0 over change in x, 6 minus 0. And you get 4/6, which is 2/3. So this equation would be y equals 2/3 x, and 2/3 is a decimal, 0.6 repeating. So use the graph to compare the unit rates. Obviously, A has a greater unit rate. The slope is steeper than B. Looking at 14, data in the table represents another moving object, object C. Explain how this unit rate compares to those shown on the graph. Okay, so for C, we'd have the same thing. Time is x, distance is y. Change in y would be 15 minus 7.5 over the change in x, 10 minus 5. And we would get 7.5 over 5. Which is 1.5. So our slope for C is 1.5, which tells us that it's actually going to be right in between A and B. So if we're looking at it on the graph, it's going to be in the middle somewhere. Let's graph it. It's not asking us to, but let's graph it. 5, 7.5, that'd be a tough plot to point, but we could plot 20 and 30. Well, no, we couldn't, because it's off the chart. But 5 and 7.5, 2, 4, 5 would be right in the middle, 2, 4, 6, 7.5 would be right around here, not exactly. The next one would be 10 and 15, 10 and 2, 4, 6, 8, 10, 12, 14, 15 would be right in the middle there. And we know that it is proportional, so it will go through the origin. So there, line C would be somewhere around there. As you can tell, that its unit rate is closer to A's than it is to B. Hiking at a constant rate. Fred covers 20 miles in 4 hours. How far predict how far he can hike in 10 hours. So, we have hours and miles. Hours and miles. Time will be X. 4 hours is 20 miles. We want 10 hours. A couple ways we could solve this. This could be set up as a proportion. And actually this would be y. This is just a variable. This is just our unknown. I guess x would be a poor variable to use. Let's use whatever you want. Use j just because I feel like it. So we could cross multiply and divide. That's how you solve proportions. Or we could see that 4 times what gives us 10. You might not see that off the top of your head. So let's cross multiply. 10 times 20 is 200. We're going to divide that by 4. 200 divided by 4. 4 goes into 25 times. And bring down the 0. So this would actually be 50. Or, if you know that 4 times 2.5 gives you 10, you can actually just multiply 20 times 2.5. 20 times 2.5 would also give us 50. So he would hike 50 miles in 10 hours. 16. A thick human hair is that big. Write this measurement in standard notation. Okay, so for 16 we have 1.81 times 10 to the negative 4th. So 1.81, the negative tells us this number is getting smaller, so we're going to move the decimal to the left 4 times. 1, 2, 3, 4. Then we have to fill these in with zeros. So we would get 0.000181. And then we should throw in that we're talking about meters.